Okay, since everyone's here, we'll get started. Does someone want to open with a prayer this time?
I'll say it.
Okay.
Dear Heavenly Father, we humbly come before Thee this morning and give You thanks for this day and the opportunity we have to study together. We pray for Thy Spirit to be with us, that we can be able to progress in our understanding of the things that we're studying this week, and we can help one another and continue to move forward. We are grateful for all that we have. These things we humbly say in the name of Jesus Christ. Amen.
Amen. Okay, awesome. Um, so go over our homework and stuff, our prep. Make sure everyone gets on the same page.
I guess, does anybody have any questions on anything, or?
Yeah. Any questions?
I don't.
Okay,
All good.
sweet.
I'm sure as we get going, I'll have some.
Yeah. Okay. Let's see. So the quiz that we have to do is like, it's kind of weird how she set it up. We have like, we have the problems and we have to like do our work and stuff, but have it downloaded as a PDF to turn in. It's not like a fill in the blank kind of quiz or anything. We have to like show our work and write everything out in PDF. So it's weird.
Yeah. It's like,
What are you thinking? You can scan it?
Yeah, I think I'll just scan it in.
yeah. Like, I was looking at the individual quiz, and it's the same thing. Like, we are supposed to do it, like, show all of our work and everything, and then send it to her.
Yeah,
Yeah.
it's kind of weird.
A little bit, yeah.
Okay, so do we want to get started on the group quiz? Make sure that's out of the way and then answer questions as we go.
Sounds good to me.
Sure.
I'm done with that.
Perfect. Make sure I have everything written down. Okay. Does everyone have it pulled up on their screens?
Yeah.
Mm-hmm.
Sweet. So we'll just start with the first one. So how do we want to do this? Do we want to just like everyone do it themselves and then go back and forth? Or do we want to just like all work out loud? how we would do it.
I'm good with whatever.
So, are we supposed to write the equation for the graph here? Is that what the deal is?
Yeah.
Yeah, so
I'm probably going to get more out
Yeah.
of it if we talk it out.
yeah.
Okay. We can do that. So
So is this piecewise? Piecewise function?
Yeah. And it's like we're supposed to do it. So I guess that might be the easiest part, is just take it apart and like do it one little section at a time.
So what's the first step you do, Chris?
Well, what I'm doing is like just look at one little line of it. So I was looking at the one that like starts on 0, 1 and then kind of heads down and to the left. And so
Uh-huh.
first we want to find an equation for that. And so we can start with that. Yeah.
is that a point at -1, 0, or is it just going through that section?
I think it is going through that section, but it's like giving us the point that it goes through so we can find like the slope and everything.
Gotcha. Okay.
Yeah.
So do we know exactly like what kind of equations they want? Because we could do a simple like slope-intercept form because we have the y-intercept and we know the slope.
I
That's
think.
what it is because. Oh, sorry. Go ahead.
Oh, that's what I was gonna say. So it's fine.
Like, yeah, because
Okay.
it is a simple line. It's not like a parabola or anything. So
Right. Okay.
figure one.
Okay. So 1x plus 1 for our first
Yeah.
equation.
Mm-hmm.
Okay. Write that down.
And then doesn't also have to be like has to be greater than or less than something too.
Yeah.
Yeah, like the domain and range. Okay. So
So it's like when I was looking at it, I think it's like so you have like the y equals 1x plus 1 and x is less than or equal to 0. Is that am I
That's
doing
what I
that right?
put down. Yeah.
yeah, that's what I figured it'd be.
Okay. And so then like the domain of that would be like negative infinity
Mhm.
comma 0.
Yeah. And it would be it wouldn't be would it be the square bracket?
For the
I always
0,
get
I
those,
think so, yeah.
okay, I always get
Yeah.
those two mixed up.
This is like what I figured out was I think that the square bracket is if it includes the number.
Oh, okay.
So kind of like that equal to thing on there.
Sweet. Okay. So is that all we have to find for the one line?
I believe so, yeah.
Okay. So now let's do the 0, 1 to 1, negative 2.
Okay.
That one. Okay, so I got negative 3x plus 1.
Yeah, that's what I got.
Yeah. Me too.
Okay, sweet. So for this one, x has to be between 0 and 1.
Yeah.
Okay.
So,
Or greater than and equal to, I mean.
yeah. So like the domain would be like this is all in closed brackets, like 0, comma 1. Because that makes sense.
Right. Because it's just in that little section.
Yeah, like it doesn't shoot off to infinity anywhere.
Right.
Is writing when we write the domain, is that talking about that x is less than or equal to 0, or does it want us to write it the other way? Because that's a way of writing the domain.
True.
Yeah, I think we'd be good either way. I'm not sure she's too particular on that.
Okay.
I think it's like as long as we can get the range and it be right, then I don't think she'd really.
And I have both ways written down just in case.
Yeah, just to be extra careful.
Okay. So we'll move on to that last little piece there.
Yeah. This one's a little different because it doesn't have a point on the y-axis for us.
Yeah.
How do you mean it doesn't have a point on the Y?
Because like that little section of line, it doesn't cross the y-axis that we can see. So like you can't just easily be like, oh, okay, well, like if y equals mx plus b, we can't just be like, oh, y is
Oh, like it did at 0 and okay, yeah,
like we did for the other two lines. Yeah.
okay.
Everybody good?
Yeah.
One more time.
What did you guys get for it?
I got x minus 3 when x is greater than or equal to 1.
X minus 3 when it's greater than or equal to 1.
Yeah.
Okay.
Wait, how did you do that? Because like I got y is equal to 2x minus 4, and then like x has to be greater than or equal to 1 and less than or equal to 3.
Well, because the slope is 4 over 4, which is just 1.
No, the slope is 4 over 2.
4 over 2? No, because it's 2, 3, between 3 and, oh, I guess that is
So it's like
3 and 1, not negative 1. So you're
yeah,
right.
like we
2
yeah
over
we go up.
4 over 2. Yeah. Okay. That makes sense. 2.
Yeah.
Yeah. So it's 2x minus 4.
Yeah, because then I just plugged it into like y equals mx plus b, and so it's like I just used that top point, so I got like 2 is equal to 3 times the slope plus b, and just kind of solved for b.
Yeah.
And I got negative 4. So
That's what I did too. My only thought about that was, can we do that same type? Because we have the endpoints of 3, 2, and 1, negative 2. So can we have it as negative 4?
well, I did do that, but then like for the domain, you do x has to be greater than or equal to 1
Mhm.
and less than or equal to 3.
Okay.
Because like then that's the 2 points that it is, you know?
Okay.
Because I mean, like if you plug in those 2 numbers in the equation, you get the y. So
Okay. Sweet. So everyone's good on how to do those?
Yeah.
yeah, I'm good.
Okay, perfect. Um, so now we'll move on to number 2. We'll start with the first bullet point for transformations.
Yeah. Well, well, we know it's going to be reflected on the x-axis because the 2 is like a negative number.
Okay.
Right? I'm not crazy.
So it'll be going down.
Wait, what?
It'll be down, is what you're saying? Reflected.
Yeah. Just because, like, yeah.
Yeah. Cubed would mean it has 2 like humps on it, right? So it's like starts to come back up.
Yeah. Pretty sure.
Okay.
You know, it's going to be what's it called? Moved horizontally 3 spaces to the right because of like the x minus 3.
Mm-hmm.
So we know it's moved to the right.
And then when it's by 2, since is the 2, what does the 2 do? Are we supposed to distribute that into the equation because it's on the outside?
It's like, well, what we're doing is we are identifying the transformations, and
Yeah.
I remember it said like that number is by how much it's stretched. So it's like kind of doubles in size kind of thing.
Yeah, but then like if you distribute the 2 between like inside the parentheses, it changes how many spaces it moves whatever direction. Doesn't it? Because
Yeah, but
it doesn't change the equation if you distribute it, but then the number is different.
well, I don't
like-
think we're supposed to distribute it because like I wrote down the equation for like all the different transformations, and it's like y is equal to a, which is like the stretching one. So that would be the 2 parentheses x minus h plus k.
Okay.
So I'm pretty sure we're just supposed to leave it as it is for now.
Okay.
Like I'm pretty sure I might be wrong.
Well, does
So if
someone have a
anybody-
graphing calculator? Because we're allowed to use a calculator.
Yeah. It's like in
Because
the
if you
syllabus.
put it, what?
I know it said like in the syllabus, like you don't have to buy one, but it's included like in the program, but I can never seem to find it.
I haven't seen it yet either.
Okay.
So it's like,
And the calculator they recommend buying is not a graphing calculator. I was a little confused why that is.
That is weird.
I think it's because then you will use the calculator to solve the problems, and then you won't be able to show your work, and then you won't get credit for the problems because you can't show your work.
I guess that makes sense. Are we not allowed to use things like Desmos? We were allowed to in my last class.
I don't know. I haven't heard anything.
Yeah, I don't know.
like I don't know.
Have you guys used Desmos before?
No.
I have no idea.
It's pretty good. It's free. It's just a graphing app. It's a site, Desmos, DESMOS.com. And you just punch in the formula and it gives you the graph.
That's cool.
Do you think it'd be okay if we use that? Because like we're not looking up the
We
answer
were allowed to
online.
in my last pre-calc class. I don't know. What's it say here?
It's like, well, I was just like thinking like it says that we're allowed to use a calculator, but we can't just like Google the question. Like we're not Googling it, we're using something online
The
to
graphing thing, yeah. That's why we were allowed to
Yeah.
use it, because it's just a grapher, that's all it is.
Mhm.
I don't know. I'll email her and ask her, see what she thinks. Because what are we confused about on this one?
whether we have to distribute the 2 into like the x minus
Mm-hmm.
3 cubed.
Do you not do the -5, -2, then distribute? We're trying to figure out if we do the distribution of the 2. Okay. Gotcha.
Well, yeah, I don't know. I don't remember doing that before, so maybe not.
Yeah.
So then it's a vertical stretch by 2.
Yeah. So that was thinking.
Okay, would saying it's a vertical stretch by 2, is that the same thing as saying it's a horizontal shrink by 2?
It doesn't.
I think so. It's just on the vertical. Yeah, I think it would look the same. It's just vertical.
Okay.
I can pull up the textbook real quick and we can check.
Okay.
Making progress. Um, So, looking at it, I don't think it's stretched over any axis. Like it just says, if a is greater than 1, then all of the y coordinates in the function are multiplied by. It is stretched by a factor of a.
Okay.
What section are you in, Chris?
Section 2.3, it says families of functions, transformations, and symmetry.
So the -5 means it goes down on the y-axis to -5.
Yeah.
Yeah, so like its y-intercept is -5.
-5. And then the -2
Is the factor. That makes sense.
Yeah. So, do we have 4 different transformations?
Let me.
the 5, the 2, the x-3, and then the cubed.
Well,
No, the go ahead.
I thought it was like right 3, vertical stretch by 2, reflected over the x-axis, and then down 5.
Yeah, so it's
Right.
like the 2 is
Reflected
the
on-
stretching factor, but then the fact that
Yeah.
it's negative is reflected.
Yeah.
So 3.
No, there's 4. So
4.
it's like the 5. Yeah,
Uh-huh.
the 5 is 1. Is 1. The 2 and the 3.
Okay.
Okay. Got him. So are we ready to move on to domain and range?
Yeah.
I think so.
Sweet.
So are both infinity?
Yes.
Okay.
Have we got into when we used the U? Have we got into that yet? Do you guys understand
The
when to use?
union. That's when
Yeah,
there's
the upside down.
an asymptote.
Oh,
So,
okay.
so then you do, because like it stops in the middle. I don't remember what graph it is. Is it the inverse variation thing one?
It's like,
Do you
I
guys know
remember
what
it
I'm
off of the homework.
talking about?
So I don't think, have we not gotten there yet? I can't remember.
I don't think we talked about that one.
Okay.
Okay. What does it mean by function family?
So there's the I think the ones that we talked about were the 6 different ones where it's like absolute value, square root function.
Oh,
But it's the
oh,
cube function.
Cube.
Yeah.
okay, yeah. Like that's what I thought it was, but I was like, I don't think I've heard it phrased that way.
Right.
Yeah.
Okay.
And then is it odd or even?
I think it's neither.
I thought it was
I don't know.
odd.
Well, I thought it
Because-
was like,
When we talked about like the odd and even functions, the odd functions are the ones
Go ahead.
where the power that the x is to is an odd number, I thought. Because it
it's like the way that I thought we did it is you plug in like x for all of the x's, and then like if it comes out to be the same formula anyways, it's even. If it comes out to be like an opposite, like all the charges are switched, then it's odd. But if it's different, then it would be neither.
So you're saying you just plug in any negative number,
You plug in negative x for all of the x's.
and then if it changes it to an even,
Like if it stays the same, like you change it all and it's still the same.
then
think-
it's even.
Yeah, let me look it up because where would that be? Oh, that'd still be in the same section. What I thought it was.
Because like the it's on I guess you don't have the book. I have like the 3rd edition book, and in that book it's on page 139.
I have that one too.
Yeah, that's what it says to do.
Negative x.
Yeah, so we just
For all
put
the x.
negative numbers in and then do the positive also, and if they're the same, then it's even, and if they're not the same, it's odd.
Hmm. Well, it's like I think it's neither, because like on in the book on example 8 where it says like determining symmetry, if you look at option C, it talks about how you place a negative in there for everything. Like the two are like this is like the x, it ends up being x squared plus 3x plus 6, and so it's like it's not completely opposite, but it's not the same, so it's neither.
Yeah, but it's a cube function, so it's symmetrical about the origin.
It's like, but I thought it was like, since it has that -5 that doesn't have an x to it, then it that means it's not gonna be exactly odd or exactly even. It's gonna be like that -5 will always be -5 no matter what you plug in there.
Right.
Yeah.
Because it's not on the origin anymore.
I don't think that has anything to do with it, because if the problem was like, instead, if it was the parabola, that's the square function.
Yeah.
If it was x squared minus 5, it would still be symmetric no matter what. Because the -5 just has to do with where it is on the
True. It still has symmetry.
origin is. Because it doesn't change the symmetry unless it does have the x on it. I think it has to have the x with the -5 for it to change it.
Wait.
Because it talks about it having the x there, right?
It talks
Yeah.
about having the what?
This one has like the 3x. It has two of the, I don't know what it's called. The one that you're talking about has two x's in the equation instead of just the one. So I think that's when it might be neither, is when there's both.
Well, the way like I thought it was is because like for this example C, if you plug in the -x, like the way it decides like if it's the opposite, then it's even. If it's the same, it's even. If it's the opposite of it, it's odd. But if you go into it and you plug in -x for all of it, so you'd still get positive x plus 3x plus 6. Like that 6 doesn't change. But for it to be, if it wanted to be even, then the negative, like the 3x should still have a minus in front of it. But because we did -x, it's now a positive 3x. And if they want it to be odd, then the x squared would have to be negative. But like the 6 doesn't change, and that's why it doesn't work.
Okay. Well, because it's saying that f of -x, so if they're the same, like if f of -x is equal to -f of x, then it is even? Or is it saying that's odd? No, I'm just wondering, like,
So
what is the rule on saying it's odd or even? If f of -x equals -f of x, then the function is an odd function. So why don't we just put negative x values and positive x values and see if they're the same in the equation. Because I don't think you can just look at an equation and say if it's odd or even.
But that's what they're doing in the example. They
Yeah, but they plug the values in and say that they're not equal.
they plug in negative x.
Yeah.
Like that's how you're supposed to do it. Like you don't need to start putting in other numbers.
Well, okay. I'm just thinking that because we did say it's a cube functions are always odd. And I don't think putting the -5 in the equation changes if it's odd or even. So I don't know.
So it says, do you see why functions symmetric about the y-axis are called even and functions symmetric about the origin are called odd?
Yeah. So
Oh. There's not an exact example of this in the textbook either.
Yeah.
well, for symmetry under section 7 and on page 139 on figure 2.48, that's a cube function. And
Oh,
they're
okay.
saying that it is an odd function because it's symmetric about the origin.
Okay.
Because even if you move the graph down 5, the origin is moved down 5, so it's still going to be symmetric about the origin.
Oh, so the fact that it's not on 0, 0 doesn't make a difference?
No.
Okay.
Okay, that makes sense.
Just like in the first example where it's a square function, even if it's moved up or down, it's still going to be symmetric over the y-axis every time, no matter where it is on it, because the values are the same on both sides.
Where's
It's
was it on?
after example 7, there's a section that says symmetry, and then there's the definition of symmetric about the y-axis and symmetric about the origin.
The thing is that the thing that I think is why it makes it neither is because it has that one variable, the -5, that is all by doesn't have an x on it. Like in the other examples, it's because of that one that will never change whether you put a negative x or a positive x. That's why it's neither. Like, and in this example, it just has f of x is equal to x cubed plus 5.
Yeah.
Can it be neither odd nor even?
Yeah, like if you go to, like, I know in the book it can. Like it is possible for a function to be neither. Like I've been saying, like C, if you look at it, it's like it doesn't. So the function is neither even nor odd, and it doesn't have any symmetry.
Because it's off the. It has like a -5 in it. Similar
Yeah.
situation.
Or so it's like the way I think of it is, so it's like if we were to so if we were to plug in a negative x for that normal x, right? It would be -5 square root of -x minus 3 cubed, right?
Mm-hmm.
But for it to be an odd function, you would have to multiply the entire thing by -1. So if it was an odd function, when we plugged in -x, it would come out to 5 plus 2, like parentheses, -x plus 3. But it doesn't do that.
What page number are you on, Chris?
I have the 4th edition, but it's example 8.
Yeah, it's on
Determining-
140.
140.
Yeah.
Did you get the hardback or are you using the e-text, Chris?
I'm using the e-text.
Okay.
And it's like option A, like, is everybody there? Or do you need more time?
It's loading up.
No.
We can table this and come back to it if we want.
Yeah, I think we might want to. Just because.
Yeah. Okay. We'll come back to that one. So now state whether it's increasing or decreasing.
Okay.
Left or right, it's decreasing, right?
Yes.
Yeah. But like, since it has that little hump, does that mean that like in that little spot where it is going up again, would that still be considered increasing, or?
No, it's decreasing the entire time. Because
Okay.
cube functions don't change direction.
Yeah, I think it just zeroes out there. It doesn't actually go up.
Okay, maybe I'm just like.
Actually, it's probably a gradual drop, right? Yeah. Kind of looks like a hump, but it's a constant drop.
Yeah. Okay. Yeah.
Okay.
So it's
So
decreasing.
the last part, we have to graph the function.
Okay.
So your point is at -3.5, and then it just makes your, or you just gonna, what do you guys usually do? Like just use -2, -1, 0, 1, 2?
Yeah. I think like the point,
I mean,
like, go ahead, sorry.
since we know what kind of function it is, you can just do the transformations to the normal one.
Just where the origin is, you move it down 5/3. That's all you do.
Well, I mean,
And
you'd have to like
stretch
draw
it
it with
like
like the points, but
Yeah.
Yeah.
So what is the -2 representing in that?
Well, the 2 represents that it's being stretched
It's
by
the
a factor of 2. And the negative in front of it means it's being reflected.
That's right. Okay. Yeah.
That -2 has like 2 parts jammed into it.
Then you just submit everything, Rachel?
Yeah.
okay. So for the odd or even, you know where you're reading the book for example 8, C?
Yeah.
It says right below it, like it explains why. And when it's explaining why the x squared plus 3x has neither symmetry, it doesn't even include the +6. So that has nothing to do with it. Like it says a function with odd exponents such as x to the third or x to the fifth minus 6x to the third plus 4x is symmetric about the origin because all of the exponents are odd. But since there's only one exponent and it's odd, then it's an odd function. Like in the second one, it says a function containing both even and odd powered terms, such as the x squared plus 3x has neither symmetry because the exponents aren't both odd or both even. So I don't think it has anything to do with the 6 term by itself, because that doesn't change.
And that was for example C.
Well, it's in example 8, there's like C, and then right below it, there's like a paragraph explaining why functions are odd or even.
Well, in this one, if you were to plug in a negative x, they'd all switch between negative and positive, and that's why it's odd. Like if you plug in negative x into the whole like x to the 5th minus 6x cubed plus 4x, everything would change. It would be negative x to the 5th plus 6x cubed
Flip to the
minus
other side of
4x.
the graph. Right.
But if you do that with a different one, like C, like, or say if it had that plus 5, it wouldn't change. Like that plus 5 would not be the exact opposite. It would still be plus 5. And that's why I'm saying that it's not symmetrical. Because if like x5 minus 6x cubed plus 4x plus 5. If you multiply the negative x in for everything, negative x to the 5 minus 6x cubed plus minus 4x. The formula isn't an exact opposite.
It's when the origin is not at 0, 0, it's not going to be the exact opposite because the origin is moved. Like, so you have to account for that in all of yours. And it's talking about if it's symmetric about the origin, if it's an odd function. But if it's an even function, then it's symmetric over the y-axis. So it doesn't matter where the origin is. I don't see why like the 5 at the end would change whether or not a cube function is odd or even. Because a cube function is always odd.
Well, the way you decide whether a thing is even or odd is you plug in negative x for it, right? And if f of negative x is equal to negative f of x, then it is odd. So basically saying, if you were to plug a negative x into that function and like did it, would they all become the opposite of what they were?
It would. The
And
graph would
so,
flip to the other side.
and so since that plus 5, if you put a negative x into it, would not change, it would stay a positive 5, is why it wouldn't be an odd. Because f of negative x is not equal to negative f of x.
Yeah, but you do the subtract 5 at the end, so you're subtracting 5 from both points, so it would move both of them down the same amount.
But I'm just looking like if we go into this, so if we were to plug in a negative x, right, it'd be negative 5 parentheses negative x minus 3 cubed, right?
Okay, I have a better idea. Rachel, you can figure out, like, you've heard both of us say, you pick what answer, and then we can look up, like, it on the internet after you submit it.
Okay.
Because, yeah.
Okay.
Sounds good.
So, whatever you think. Because we're just saying the same thing over and over again.
Going in circles.
Yeah.
Okay.
Is there anything else we're supposed to talk about?
I think that's it.
Okay.
No, I think that's it. I'll turn this quiz in a little bit later today.
Okay.
Okay.
But I think that's it.
Cool.
Awesome. See you guys next
Unless
week.
there are any other questions.
Yeah. See you Tuesday.
Okay. Bye.
Okay, we're good. Have a good week, guys.
Yeah.
See ya.